already in 8th standard, we have a lesson number 1. Same again, number system. So before we start with the number system, first of all we have to understand the following term. So first is, what is natural number? What is the meaning of natural number? Natural number start from 1, 2, 3 and 3 dotted means infinity are called natural number. It is denoted by n. In set form we can write in curly bracket 1, 2, 3, 4 and 3 dot. We can also represent in number line rational number. Afterward, natural number, then whole number. So if we add 0 to the natural number, we can say it is a whole number. In your text first page there is a one page in which whole natural numbers are there. So we can also draw like it. If there is a one bag in it, I have to put 1, 2, 3, 4. Then it is called bag of natural number. Now if I add in the bag this, if I add 0, then it is called whole number. If I add 0, then we can say whole number. So natural number is one of the bag that we have represented in number line. Now if I will add 0, it will be the whole number. But in MCQ 1 marks questions or in GK based, smallest whole number is 0. So first is natural number. It is also infinite. We cannot count any number. Natural number is called infinite number. Whole number. Again, if we add 0, then it converts into whole number. Now, integer. Collection of all the natural number, their opposite. So collection of natural number, whole natural number and their opposite. So if I will take 1, 2, 3, 1, 2, 3, opposite is -1, -2, -3 and infinity. And 0 is added to it. It is called integer. What again definition of integer is? Collection of all natural number, their opposite and 0 is called integer. It is denoted by the z. What is the meaning of z? Z actually meaning of zählen in German. We can say zählen means to count. That is why we are using symbol as a z. Again, it is also infinite many number. Integer is also infinite many number. We cannot count it. So in curly bracket we have to write z is equal to 3 dot -3 -2 -1 0 1 2 3 3 dot and then curly bracket over. Afterward there is a rational number. If p and q are integers, it means what? P and q are integer and q not equal to 0. It means numerator upon denominator. Denominator is not equal to 0. Then the number which can be written in form of p upon q is called rational number. Again we define. If p and q are integers and q not equal to 0, then the number which can be written in form of p upon q is called rational number. It is denoted by the q. The word rational, from where it is? The word rational comes from the word ratio. In rational there is a one term that is ratio. So the word rational comes from the word ratio and the q comes from the word question. Therefore we are using as a symbol as a q. Again, the word ratio comes from the word ratio and the q comes from the word question. So in curly bracket we can write like that: p upon q, where q not equal to 0 and p and q are integers. P and q are integers. That we can write in curly bracket. So first of all, again, to important of all, that is last is important, because all natural number are included under the whole number. All whole number are included in the integers number. We can say like that. All whole number are under integers. All integers are under the rational number. So in subset definition we can say natural number is a subset of whole number. Whole number is a subset of integer, that is z, and integer is a subset of rational number, that is q. So generally maybe asking exercise in first exercise already there is some question that every natural number is a whole number. We can say yes. Integer is included in rational number. Now that is we can say yes. So natural number is subset of whole number is subset of integer, integer is subset of rational number. But in opposite we can say no. So means every rational number in this question, every rational number is an integer, we can say no. Every integer is a whole number, we can say no. Every whole number is a natural number, we can say no. Now we go further, that is rational number but equivalent. So in rational number we can go further. One of the called equivalent rational number. So 1 by 2, 2 by 4, 4 by 8, 8 by 16. We can say it is equivalent rational number. Another thing is that a rational number is either terminating or non-terminating recurring. Rational number is either terminating or non-terminating. So we can write 1 by 2, 1 by 5, 1 by 25. So these are all called terminating number. Why? Because if we divide it, we can get answer in decimal. So that is why we are using. We can say that it is terminating number. Why? 1 by 3. If I write 1 by 3, then it is called terminating but recurring number. Non-terminating, either terminating or non-terminating recurring. Terminating means end. One of the best word is end. Whose number ends is there, we can say terminating. Now 1 by 3. It is not possible that it has an end. If you divide, we can get answer. So it should be continuous. 3, 3, 3, 3, continuous. So we can say 0.3 bar. So it is called terminating. So again, everything related up to the natural number, whole number, integer and rational number we can complete. In rational number we have to, again, when number which is not rational, we can say irrational, or the number which is not representation in number line, we can say irrational number. So in next video, next topic we want to continue, that is irrational number and real number. So rational is denoted by Q and irrational number is again denoted by Q bar also, or we can say I. Rational number between given two distinct rational number. But we know in 8th standard that in number line we can say the infinite rational number between given rational number. Rational number between given two rational number means infinite rational number between two number. So how we can find out? So there are different ways that is given in our textbook. But now we have to discuss 3 examples related it. So first question is find 6 rational number between 3 and 4. What we have to do? Find 6 rational number between 3 and 4. So simple, 6 plus 1, 7. So what we have to do, just we have to multiply both terms by 7. So first of all, rational number should be in P upon Q form. Here Q is not, so we will write 1. So 20 1 by 7. Now 4. So 4 upon 1 multiplied by 7, that is 28 upon 7. So between 21 upon 7 and 28 upon 7, there is always 6 number which is between it. Let me discuss that it is correct or not. So 21 by 7 and we have to write 28 by 7. Between it we have to write, that is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. 1, 2, 3, 4, 5 and 6 number. So that is a shortest way and easiest way which is not given in your text. So again I repeat, to find out any number, find 6 rational number between 3 and 4. So 6 plus 1, 7. 6 plus 1, 7. That is, we have to multiply 7 numerator and denominator both. Then we can get easily. So this is really the first sum. Now we can do the second sum also. So in second sum, if you will read, how many terms are there? 5 terms are there. So we have to find rational number between 3 by 5 and 4 by 5. Now again what I have said to you, 5 is there. So 5 plus 1, 6. So what do I have to do? 3 by 5 multiplied by 6, both numerator and denominator. And 4 by 5 multiplied by 6. So 18 upon 30 and 24 upon 30. Now if we will check between, that is 18 upon 30 and 24 upon 30, there is a 5 number which is between it. We can say 19, 20, 21, 22 and 23. So we can easily find out this number. Now, so that is a one more example. Still now we can check further. Now in this you will see that denominators are not same. In first example, denominators are not given, so we have to write 1. In second example, denominators are same. But in third example, denominator is not same. Then what we have to do? So first, if there is a denominator is different, then we have to find out first LCM. So if you will see that 3 upon 5 and 2 upon 3. So 5 and 3 LCM is 15. 5 into 3 LCM is 15. So what I have to do? First of all, I have to make denominator equal. So 3 upon 5, both sides I multiply. 5 3s are. So now question is converted into 9 upon 15. Now 2 by 3. 2 by 3. Again I have to multiply. LCM is 15. So 5. So 15 upon 5. Now again what I have to multiply here? Both sides 3. So 9 by 15. Here 5. So 10 by 15. Now how many numbers we have to find out? 5. So 5 plus 1, 6. Always remember 5 plus 1, 6. So we have to multiply numerator and denominator. We have to multiply numerator and denominator by 6. So you will see that 9 6 are 54 and 15 6 are 90. And our second number is 10 upon 15. 10 upon 15. We have to again multiply by 6. That is 60 upon 90. How many number we have to find out? 5 number we have to find out. So between it, that is 54 upon 90 and 60 upon 90. Between it, 5 number which is between 54 and, so we can write 55, 56, 57, 58 and 59 upon 90 upon 90 upon 90 upon 90 upon 90. So that is we have discussed three different examples that is in your exercise. Same type of sums are there that you have to represent it. Rational number between given two distinct rational number. Again we know that it has an infinite many rational number between two number. So in first example 3 and 4, how many number? 6. 6 plus 1, 7. In denominator here there is not given, so we have to take 1 and multiply both sides. In second, already 5 is equal as a denominator. But in third example, 5 and 3, they are not equal as a denominator. So what we have to plan first? Take LCM. First of LCM and make denominator equal. Then what we have to do? 5 plus 1, 6. Both sides multiply by 6 and we can get sum. So that is the topic related to the rational number between given two rational number. Friend, today I want to discuss related with the irrational number and real number. So first of all we have to define what is the meaning of irrational number. So before we define, we have to remember the rational number, because if you will know that is rational and irrational. So the number which is not rational, we can say it is a irrational number. The number which is not rational is called irrational number. A number whose decimal form is neither terminating nor non-terminating recurring. It is the definition of rational number. All rational numbers we know that they are terminating and they are non-terminating recurring. They are terminating and non-terminating recurring. It means irrational numbers are neither terminating nor non-terminating recurring number. It cannot express in form of P upon Q. We cannot express on P upon Q means rational number. Rational number symbol is Q and we can represent the P upon Q form of rational number. So rational number, the irrational number cannot be expressed in form of P upon Q. Then which type of numbers are irrational number? The number like root 2, root 3, root 5, square root of 10. There is different type of number. Those who are under root in form. Generally we are taking the prime number in form of under root 21. As an example we can take under root 21. We cannot write under root 25. It is not a irrational number. Why? Because under root 25 is 5. So root 25 is not an irrational number. So now tell which type of number? The decimal form of irrational number is non-terminating, non-recurring. Non-terminating means which has no end. जिसका end नहीं है, जिसका अंत नहीं है, that we are called non-terminating. And non-recurring, वो recur वापिस दूसरी बार तीसरी बार नहीं आएगा. That is we can say non-recurring. So non-terminating, non-recurring number like you will see that 0.0.01, 0.001, 0001. So there are, we can say that here it is not repeated. Here it is not, we can say repeated because of 01, 001, 301, 401. So non-terminating, non-recurring. One more example, 0.231, 2311, 23111, 23111. Continue. 3 dots it means continuous. 3 dot means continue. So you will imagine or we can understand that irrational number are simple. We can say that irrational number are simple which are not rational. Generally symbolic form of rational is Q and irrational number is Q bar. So if we will join, there is one number we can get that we call real number. Again rational union, it's sign of union. This means हम लोग उसको combine करेंगे. किसको combine करेंगे? Rational और irrational number को अब जब combine करेंगे तो we can get real number. So from next topic we have to concentrate on real number. हम लोग अभी किसके बारे में डिफाइन करेंगे? रियल नंबर का डेफिनेशन डिफाइन करेंगे. So already from we know that collection of all rational number, collection of all rational number and irrational number, collection of all rational number and irrational number is called real number. It is denoted by R. Real number. Real number, it is denoted by R. Each real number can be represented as a unique point on number line. Generally we know that real number means what? Rational and irrational. So already we know that rational number can be represented on number line. It means just we have to understand that now irrational number also can be represented on number line, because each real number can be represented as a unique point on number line. Real number can be represented. It means root 2, root 3, root 5 can be represented on number line. So हम number line सीखते हैं, या if we want to represent irrational number on number line, we have to remember the one great mathematician, that is Pythagoras. We have to remember the Pythagoras. So to understand properly real number, first of all, what we have to plan? We have to understand the rational, irrational, that we already understand. So rational plus irrational, you can say real number. Real number can be represented on a number line. It means now we have to understand how we can represent irrational number on number line. So before you understand that, we have to remember the great mathematician Pythagoras. हम लोग Pythagoras के बारे में थोड़ा इंफॉर्मेशन लेंगे, उसके बाद irrational number को number line में रिप्रेजेंट करेंगे. So what the Pythagoras say? Pythagoras is a great mathematician of Greece, from Athens. So if Pythagoras say that in any right angle triangle, what the Pythagoras say? In any right angle triangle. So here if you will see that triangle OAB, so angle A is equal to 90 degree. So any right angle triangle, Pythagoras say that angle opposite side, 90 degree angle opposite side, square, that is hypotenuse square, is sum of its adjacent side. उसका जो स्क्वायर है वो 90 डिग्री जो एंगल बनाता है, उसके जो बाजू वाली साइड्स है उसी के स्क्वायर को प्लस करेंगे, we can get hypotenuse. So OB square is equal to OA square plus AB square. Now we can, because if we will understand properly, then we can understand represent root 2 on number line. Represent root 2 on number line. हम लोग कैसे रिप्रेजेंट करेंगे root 2 को नंबर लाइन में? तो first of all I will take one at here. If I will take OA is equal to 1 unit, again here is also 1 unit. So 1 unit square plus 1 square. So OB square is equal to 2. 1 plus 1, 2. So OB is equal to root 2. Means here we have get root 2. Now what we have to do? You will see that we can represent a number line. So here value of root 2 is there. So we can represent root 2 on number line by applying Pythagoras. So we have to remember the Pythagoras, and by using Pythagoras theorem we can represent irrational number on number line. So root 2, we can also do root 3, root 4. Root 4 it means 2. So root 3, another method is that we can take again 1 unit at here, 1 unit at here. Now if I will join that O, B and See, now if you will see that OC square is equal to OB square plus BC square. So OB square, that is root 2 square plus 1 square. Root 2 square is 2 plus 1, that is 3. OC square is equal to 3. Therefore OC is equal to root 3. So we can say 90 degree. Here it is a root 3. Again we can do it number line. How we can do it? We can make a point and pencil and dot dot dot. We have, if you come at here, so we can get root 3. So to get root 3, what is our target? First of all, I have to find out the root 2.